Now, this video, the hyperbola, our 1 on x type graphs. If you were to do up a table of values, you should be able to see that this shape comes out quite readily. So if x is very, very small and positive, like in here, it's going to produce very large positive y values. If x is very large and positive, 1 divided by a large number would be small positive, and then the same applies for the negative. So anything that's got this shape is a 1 on x graph or a hyperbola. Now, the axes are our lines of asymptotes at the moment. So here, the line y equals 0, in other words the x-axis, never gets breached. So the graph will never cut it. So there's no value of x that I can put in here that will make y become 0, since it never cuts the x-axis. And conversely, x can never be 0, in other words the y-axis, x can never be 0 because 1 divided by 0 is an illegal operation. So they're my lines of asymptotes. But if I were to add some value on the end, every single one of those points would now shift up. So the graph would be exactly the same shape, but it would shift up. So instead of being asymptotic to the x-axis, it's now going to be asymptotic to whatever I choose to put on the end. And then, of course, it's like that. In this case, there will be an x-intercept, easy enough to work out. Now, I don't really have to do that. I can also do things like this on the bottom. So again, remember, a divide line acts like a set of brackets, so I now have a number inside the brackets, so straight away you know it's going to shift the graph left and right. So on that particular one, the k has shifted it up like that, but the h inside the bracket, minus inside the bracket is going to be a positive shift, so this vertical axis, asymptote, now gets shifted over to here. So in that circumstance, this shape just gets shifted around. And we can see there will be an x and a y intercept. Easy enough to work out. And there's your asymptotes where the line doesn't exist. So that's going to be at the line y is equal to k. The vertical asymptote is at the line x is equal to h. And then the only other thing that we can do is multiply through by a on the top line. And a has the same effect as in quadratics and cubics. It's the dilation factor. But whereas in quadratics and cubics, if a is bigger than 1, the graph gets closer to the y-axis. It's the reverse here. As a gets bigger than 1, the graph gets further from the y-axis. It spans out. And obviously as a is less than 1, it gets closer to the y-axis. So there's the general properties that you need to know. That's the general form, dilation, and x, so k and h being the asymptotic lines that you're going to draw to. So let's have 2 examples to see how we're going to use that. So let's draw this. Firstly, let's work out our h and k values so we know how the hyperbola has been shifted around. So h is going to be equal to -2, k is equal to -4. So if I would start drawing up my graph over here, so h is what's going to shift it left and right. So this one's going to shift 2 places to the left. So there's my normal x and y axes. I go to -2 now on the x-axis. There's my vertical asymptote. The number on the end, -4, shifts the curve up and down. That's the k value. So I now go down to -4, and that's going to be my horizontal asymptote. And so my curve is going to be drawn one here, one here. So let's go through and work out where it cuts the x and y axes. So you might want to pause the video, work out where this is going to cut the x and y axes, and then come back and see if we agree with each other. So here's what I think. I reckon that the y-intercept should occur at -3, just here, and then the x-intercept should occur at, badly done, half, -1.5, so around about there. And that makes sense because we know that the original function has got the curvy bits in these 2 quadrants here. It's been shifted like that. So there's going to be one curve here be asymptotic that way, and then the other part of the curve is going to be asymptotic that way. And that's what it's going to look like. Let me just rub this off. I'll give you one more where we go backwards. I'll give you the graph and ask you to work towards the function. Now, let's have a look at this one. Hopefully when you're looking at this, the very first thing that jumps out at you is that it has been switched around. All the ones I've done so far have had the curvy bits in this quadrant and this quadrant. It's switched over. So that implies that my A value is probably going to be negative. But let's see what happens. First of all, let's work out H and K. So K shifts it up. So it has to be equal to 3. H shifts it left and right. So H has to be equal to positive 2. So, using the general form of y equals A over x minus h plus k, I've got the general structure of it. All I need to do is work out the A value. I just need one more piece of information from the graph, and I could use this coordinate or I could use this coordinate. It doesn't really matter. I'm going to use this one. So I'm going to use the point 40 and put it in. You might like to pause the video now, have a go, put 40 in and see what A value you end up with and see if we agree. Now, as suspected, A came out to be negative, so therefore I can say that my final equation is going to be y is equal to negative 6 over x minus 2 plus 3. Alright, see you in class and we'll try a few more of them. So best of luck.